This is my video solution to one of the problems on the first exam for Chem 1315. Alright, so the question asks to add all the implied hydrogen atoms to the structure of intermediate 6 before, and also indicate the hybridization of the central angle in 6b, assuming the bond angle of 120 degrees. So what we're going to do first for part A is to look at each of the carbons in the ring and see how many bonds are attached to the carbon. So the carbon at the start has 4 bonds, and carbon can only have a maximum of 4 bonds. So therefore, we know that there's not going to be any hydrogens present in that carbon. The one to the left of that carbon, we have that it's 3 bonds, 1 of the single bond and 2 of the and then 2 bonds from the double bond, and so we know that's 3 bonds. So that means there has to be a hydrogen that is attached to that carbon. And going counterclockwise to the next carbon, we see that that carbon is attached to 2 carbons, so it has 2 single bonds. And to make 4, we know that that carbon is going to be attached to 2 more bonds. When we go to the next carbon, it's going to have the same principle that there's 2 single bonds that it's attached to, and so it's going to have 2 carbons that that carbon is going to be attached to. And the same thing is going to happen with the next carbon. The last carbon has 3 bonds, the single bond and 2 bonds from the pi bond. And so we know that's 3 bonds in total, and carbon, to have a full octet, will form 4 bonds. So therefore, we know that there's going to be 1 hydrogen there. So the implied hydrogen structure should look like this. There should be there should be 1 hydrogen at the carbons where there's 3 bonds, and 2 hydrogens at the carbon when there's 2 bonds, and the carbon that is starred will have 0 hydrogen since it has 4 bonds. The hybridization of the central carbon and the carbon that is starred. So to look at hybridization, we see how many atoms that carbon is connected to. So in this case, the carbon is connected to 2 other carbons. So we would think that the hybridization of the carbon that is starred would be an sp hybridized. However, we know that the bond angle is going to be 120 degrees, and so we know that it can't be sp hybridized because sp hybridized carbons have a bond angle of 180 degrees. So that 120 gives us a clue that the hybridization is going to be an sp2 hybridized, and more specifically, it's going to be a trigonal planar carbon.